Hello, and welcome to a lovely session of solving a bunch of questions related to and swimming around the general topic of quadratic equations. I'm going to be going over some worksheets here, basically going through and solving all of them for you. And we're going to talk about how we get there and what that entails. So, my first sheet here that we're taking a look at is basically just solving via square roots. And this is a very straightforward process. Uh, as long as it is written as number squared equals variable squared, then you're just going to go square root of both sides and say that the variable is equal to, and then you're going to do the square root. So obviously with this number 2 here, which is k squared equals 16, we just say the square root of k squared is equal to the square root of 16, and therefore k equals 4. Now, it really should be that you technically are going to write this as plus or minus, because if you'll note, if you plug a -4 into this original equation, -4 squared, -4 times -4 is 16 with two negatives. That becomes a positive. So yes, -4 does work. So even though this says k equals 4 is the answer, I don't actually like that result. It really should say plus or minus 4. But we're going to continue here and we're going to say, all right, so the square root of a squared versus the square root of 4, because we're trying to undo the square, of course. And so we're going to end up with a equals the square root of 4 is 2, and that again should be plus or minus. Now, what about number 6 here? Well, number 6, we've got a 2n squared. So in order to do this process, we really need to strip away all the numbers. You need to think of this like you're doing a regular equation, right? If you have like 5x plus 7 is equal to, thinking ahead, 22, right? You take away the numbers one by one. So you say there's a 5 in the way, there's a 7 in the way. I need to take care of all those numbers. The 7 is the number that would be interacted with the x last, so we remove it first. We strip it away layer by layer. And what we are going to do in the case of number 6 is no different. We are going to say, well, we've got a square and we've got a multiply. And so we're going to need to get rid of the times 2 because order of operations says we would square before we do times 2. So let's get rid of this times 2. And so we get n squared is equal to -72. So arguably then n is plus or minus the square root of -72. Now here's the thing. You can't technically do the square root of -72. It is an imaginary number. Now, if you're familiar with imaginary numbers, you can do this. You can raise the square root of 36 times the square root of -1 times the square root of 2 and say this is 6 times I times square root of 2, which means you would probably then write this as plus or minus 6 root 2I. However, you can see quite clearly the answer on the sheet is no solution because they're assuming that you're going to be giving a non-imaginary answer. And the same exact thing is going to happen here for number 8. If we divide by 7, we get x squared equals -3. Once again, you have something squared equaling a negative. As you know, if you square a positive, you get a positive. If you square a negative, it becomes positive, so there is no way to get a negative. Obviously, this is going to be no solution, but if we tried to go ahead with it, we would get square root of -3, plus or minus, and therefore we would have root 3 times I. But number 10, we've got some negatives, and this one works out because we're going to divide both sides by -5. And that means that we now have x squared equals 100. And this looks exactly like our first several problems. We'll square root both sides, and we end up with x equals plus or minus 10. Number 12, we'll divide by -2 on both sides. K squared equals 81, and then plus or minus 9 by the same argument. Now, what's going on with 14? It says 14 has no solutions. That's interesting. I don't know that I agree with that. So let's divide by 16. And so that doesn't simplify nicely. So we're just going to leave it as 49 over 16. And now we'll square root it. And we get n is equal to plus or minus. Square root of 49 is 7. The square root of 16 is 4. I would write this as plus or minus 7/4. So I'm not really sure why this says no solution, but this right here would be my set of answers for this particular page. Okay, so moving on, I'm going to scroll this down now, and we're going to look at another page, which is more of the same, but obviously a little bit more complicated. I'm still going to stick to just the evens for the sake of demonstration. So we're going to once again isolate our squared first by doing -8 to both sides. So we have n squared equals 72. So we square root both sides, and n is equal to plus or minus the square root of 72. Well, all right, we got to break this down. 72 is 36 times 2. And 36 is a perfect square, which is why I picked that rather than, say, 4 times 18 or 8 times 9, although 9's a square. But 36 is the largest square that I could pick, so I'm going to go with that. And we're going to say plus or minus 6 root 2. And there's our solution. All right, 18 says no solution. We'll find out about that. 10n squared plus 2 equals 292. So we'll subtract 2 from both sides. 10n squared equals 290. And then we'll divide both sides by 10, and we'll get n squared equals 29. And now that's not going to simplify nicely because 29 is not a perfect square. In fact, it's a prime number. But if we were to square root both sides, we would say n is equal to plus or minus the square root of 29. So there are solutions. They're just not whole number solutions. All right, number 20, we'll subtract 10 from both sides because we got the square, the 9, and the 10. And in sequence, we would want to, if we knew what n was, we would square it, and then we would do times 9, and then we would do plus 10. So to strip away those layers, we'll take away the outermost thing first, which is the plus 10, by doing a minus 10. 9n squared equals 81. Okay, well, now the 9 is the outermost step, so we're going to say n squared equals 9 by dividing by 9. And now we square root both sides and we get n equals plus or minus 3. Okay, 22. That is a funky looking answer, whatever they wrote there, but we'll figure out what this actually entails. 8n squared, we're adding 6 to both sides. We get 8n squared equals 312. Okay, does 8 go into 312? I'm going to have to bust out a calculator to check on that one. And yes, it does. It goes in 39 times. So therefore, when we divide by 8, we have n squared equals 39. So now when we square root both sides, n equals plus or minus the square root of 39. 8n squared minus 4 equals 532. I doubt that that's no solution. We'll add 4 to both sides. 8n squared equals 536. Then we'll need to divide by 8. So let me come back to my calculator off screen here, and that is 67. N squared equals 67, and I'm pretty sure 67 is a prime number as well. So I'm going to claim that this is n equals plus or minus the square root of 67. I should take a note that I'm not being super neat about how I'm writing this because I'm doing this with a mouse rather than a pencil. But if you were going to hand this to your teacher, you probably would want to make it look a little nicer than this. Just saying. So do as I say, not as I do on that front. All right. So adding 7 to both sides for number 26 here. 8b squared equals 200. Divide both sides by 8. And finally, we will square root both sides and get b equals plus or minus 5. All right. This last one looks a little gross. Root 5.5, we'll see. All right, so we're going to look at this. Think of this as negative 4x squared plus 3 if you have to. Either way, we're going to take the 3 away. So we have negative 4x squared is equal to negative 88. And now we will divide by negative 4 on both sides and get x squared equals 22. Okay, so now we will square root both sides. X equals plus or minus the square root of 22. And that is our complete set of answers for this page. So I will clear and I will scroll down and we will take a look at page number 3. Now on page number 3, we're going to be doing something a little different. This isn't just solving by square roots. So in that case, And yes, I'm going to do all of them on this page. We're going to be solving with the quadratic formula. So let's remember, first of all, that the quadratic formula goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to write the rest of it with the pen tool, don't worry. So I need a square root here, and I need a plus or minus. I don't have those keys on the keyboard. All right. So let's take a look at what's going on. Now, number one, you can solve by factoring, but the instructions say with the quadratic formula. So we're going to do it with the quadratic formula, even though I could very easily write this as m minus 7 times m plus 2. And I would much prefer to do it that way. But since it's not, the instructions say otherwise, we're going to say, all right, a equals 1, b equals negative 5, and c equals negative 14. Because we're just going to look at the numbers in front of each of the terms. This is a ghost 1 here. We do take the negative sign with our numbers. We treat it as plus negative 5 and plus negative 14, so that's how we end up here. And now we have to go through and execute the quadratic formula. So x equals negative negative 5, which is a fancy way of saying 5, plus or minus the square root of b squared, 25, minus, all right, I don't think I'm going to do this one in my head. So 4 times 1 times negative 14. And we take this all over 2 times 1, so over 2. All right, let's break this down a little. 5 plus or minus the square root of 4 times 14 is 56. We've got a minus and a minus. That's 2 minus signs, so it's 25 plus 56 over 2, which is 5 plus or minus the square root of 81 over 2, which is 5 plus or minus 9 over 2. Now that is two solutions, so we're going to need to write them separately. We're going to need to recognize that we've got x equals 5 plus 9, 9 over 2, and we've also got 5 minus 9 over 2, which in turn is 14 over 2, negative 4 over 2, or in other words, 7 and negative 2, which is exactly what the solution says it should be right here. However, again, this would have been much easier to get to by factoring. Unfortunately, we're not factoring, so I think I will probably pass on doing every last question, but I do want to do a couple more of these, starting with number 2. Number 2 is interesting here, so I'll change text color. So for number 2, we want to look at our coefficients. The coefficient on the squared term is 1. The coefficient on the linear term, the just regular old variable term, is negative 4. And the coefficient on the loose number, or just, I guess I should say the loose number, the constant term, is 4. Now I realize I'm using the letter b here, even though there's a b for our variable. I guess I should actually come back here. This is not x, this is m. So I should be proper and write whatever variable they use here. But in this particular other question here, number 2, we're going to say then that the variable b is equal to negative our coefficient b, so negative negative 4, or 4, plus or minus the square root of b squared minus 4 times 1 times 4 over 2a. Now, maybe you can see ahead, but 4 times 1 times 4 is 16, and 16 minus 16, this square root here is 0. 4 plus or minus the square root of 0 over 2. So this is interesting. This is a very specialized case here. What is the square root of 0? Well, what number squared is 0? You can, in fact, square root 0. You say, well, 0 squared is 0, so the square root of 0 is 0. All right, well, that's just a 0. So plus or minus 0, we don't care. It's just 4 over 2, or in other words, 2. Now, that does present an interesting situation because quadratic equations have two solutions. By definition, anything that's to the second degree will have two solutions. Anything to the third degree will have 3. That's true of all polynomials. So where's our second solution? Well, to answer this, I'm going to factor this and show you what this would look like factored. So we need to split this up into b and b, and we've got a minus for our middle term and a plus in the back, so we need two minus signs. So we need adds to 4, multiplies to 4. That's obviously 2 and 2. So either b equals 2 or b equals 2. I'll write the squiggly brackets to say the set of these numbers here. And, well, there's not really any reason to say 2 twice, but the answer to the question I'm posing is our second solution is also 2. It is what is known as a repeated root. Or you could say it is 2 with multiplicity 2. That's a very, very fancy word that you usually don't hear in Algebra 1, but you will experience it in Algebra 2 and or pre-calc. So I'm going to toss that out there now. So yes, there is in fact just one solution, and the reason for that stems with the value under the square root. So when talking about the quadratic formula, we've got our negative b plus or minus all business. When you talk about what's under this square root here, this stuff right here is known as the discriminant. And not the square root part, just the numbers underneath. And what happens is when the discriminant is greater than 0, you have two real roots, like you have in most questions like you're expecting. And when the discriminant is less than 0, now you've got the square root of a negative number. Well, square root of a negative also automatically means we're dealing with imaginaries, so now you have two complex roots, which are conjugates, by the way. So if you've learned about conjugates, you'll know exactly what I'm talking about there. The third possibility, though, is when the discriminant is equal to 0. I need to spell it correctly. And that is one repeated root. And this text box is not cooperating with me. There we go. Okay. So this is the rules that we need to follow. Oh, that's a bad place for that. These are the rules that we follow when it comes to talking about how many solutions will we have. So if your teacher asks you a question, how many solutions will it have? Well, you don't even have to look at the negative b and the 2a part. You just look at what's under the hood of this square root here, and that will answer your question for you. So do keep that in mind. Now, for number 3, I'm going to shortcut number 3. This is not something that necessarily everybody would do, but I'm going to note that everything here is a multiple of 2. I'm just going to multiply both, or I guess divide both sides by 2. And I'm going to write this as m squared plus m minus 6. And that's going to be a much easier equation to solve because the numbers are smaller. Do you have to do that? No, it would work out the same. But in this case, a is now equal to 1, b is 1, and c is negative 6. So we'll go through our quadratic formula. I'm going to do the rest of these a little quicker now because I want to keep moving forward. So negative b, negative 1, plus or minus the square root of b squared minus 4ac. So negative 4 times 1 times negative 6 is plus 24. All over 2a is 2. 1 plus 24 is 25, so that's 5. So we have negative 1 plus or minus 5 over 2. And now we do need to simplify this. So if I do the plus 5 version, that's negative 1 plus 5 is 4 over 2. So we get 2. If I do negative 1 minus 5, that's negative 6 over 2. That's negative 3. And so our solution set is negative 2 and negative 3. And technically, you should be writing this in those squiggle brackets, aka braces. I know not everybody is comfortable writing those, and I know not every teacher enforces that, but this is saying the group of answers that is 2 and negative 3. This is putting it in a set. And so the set of answers is 2 and negative 3. So that's why we write it like that. Okay. So number 4, I have is number 4 going to come out nice? I think number 4 will come out nice given the answers here. 5 is very easily done with factoring or solving. 6 is the same kind of deal, but let's take a look now at number 7. There's something different about number 7 that we need to address. And that is that every single time that we've been using the quadratic formula, I didn't specify this at the top of the page, but I'm hoping that you know that the setup for the quadratic formula is that you have to have it written in the following way. It has to be a x squared plus b times x plus c equals 0. Now, I've been referencing this a, b, and c like I'm assuming you know where I'm taking them from. Um, the a is in front of the x squared term or whatever variable you have squared. The b is in front of the normal variable without the power, and then the c is the loose number. But there is one important part of this that we've been overlooking because it's already been part of the question every time, and that is the equals 0. You absolutely must have your equation equal to 0 or this will not work. Everything that we are doing to solve quadratic equations, whether you are factoring or using the quadratic formula or completing the square or graphing and finding the x-intercepts on the graph, every single method that we have for solving the quadratic formula is or solving a quadratic equation is rooted in something called the law of zero products property. It's the rule that says when x times y equals 0, either x is 0 or y is 0. That is the rule we are using. We know that when we multiply two things and we get a 0, something is 0. And if we don't have a 0, we can't do that. This doesn't work for any other number. You can't say, oh, well, when it equals 4, then either x is 4 or y is 4. No, that doesn't happen. So in order to do any kind of question like this, we always have to make sure the very first thing we do is we make this equation equal to 0. Well, currently it equals 4. I'm going to make it 0 by subtracting 4 from both sides. So now our equation becomes 4b squared plus 8b plus 3 equals 0. And now we can go through all the steps we went before. Our lead coefficient is 4, our middle coefficient is 8, and our back number is 3. And so we have negative b plus or minus the square root of b squared minus 4 times 4 times 3. I can do that in my head. If it's 48. Don't be a hero, though. If you're not sure, if you're likely to screw that up, don't do it in your head. Over 2 times a, which in this case is 8. Okay, this is the first example I've done where there was a lead number that was not 1. Obviously, number 3 had a lead number that was not 1, but I rewrote the question so it didn't. So this is the first time we're dealing with something on the bottom that's not 2. So we'll have to keep that in mind. I don't think it's going to matter here. And oh yeah, by the way, this is the variable equals. All right, so simplify this. Negative 8 plus or minus the square root of, this is 16, so the square root here is 4 over 8. So we have negative 8 plus 4, which is negative 4 over 8, or negative 1/2. And we have negative 8 minus 4, which is negative 12. Negative 12 over 8 is negative 3/2. If you don't believe me, write it out in a couple steps, and you should get the same thing. Okay. And finally, this last one says no solution. Is it really? Well, let's find out. First of all, it's not equal to 0, so let's fix that. We're going to add 10 to both sides. I really hope that this font is large enough that you can see it in the video. I know it's going to be smaller on a YouTube screen with the resolution and all that. So it's -3 on the back there now because we've added 10 to it. All right. And yeah, this is going to be a no solution, or at least no real solution. But we're going to look at this and we're going to say, well, A is 2, B is -7, and C is -3. Okay, so let's carry on from here. We've got M equals, and I notice all these are M or B. Why are there so many M's and B's here? And look, I guess there are a couple X's on the problems I didn't do, but that's weird. All right, square root of plus or minus. Now what do we got? We've got negative B. -7 is 7. -7 squared is 49. Minus 4 times 2 times -3. So -4 times 2 is -8. -8 times -3 is +24. All over 2 times 2, which is 4. Okay, equals 7 plus or minus 49 plus 24, so 53, 73, square root of 73 over 4. Now, this is not an imaginary set of answers, but there is no way we can break down 73. So, in honesty, I would probably just leave the answer like this, as written, because we can't do anything else with it. There are some teachers who would make you write the plus and minus separately. So they make you write 7 plus square root of 73 over 4, comma, 7 minus square root of 73 over 4. And if that's how your teacher wants it, you do it that way. The other thing teachers might do is they might ask you to split up this fraction and write it 7/4 plus or minus the square root of 73 over 4. Or in fact, that square root of 73 over 4 could also be written as 1/4 square root of 73. So you may see that kind of notation from time to time. That is how we write the proper form for a complex number. If instead of a square root, you have an I. So I do want you to be aware that that could be a thing. But that is going to do it for what I want to show you on this third page. So now we're going to scroll down and we're going to do one last page here. And we're going to take a look. Actually, we have 2 pages worth of this though. So these are going to be a lot more complicated of questions because it's asking us to use factors or zeros with synthetic division. So we're going to have to talk about how to do synthetic division here. Synthetic division. So steps for synthetic division. Synthetic division. So first of all, the setup. You're going to make 3 rows. The top row has the coefficients that you're dividing by. Middle row is empty. Bottom row is empty for now as well, but you're going to have a line between the middle and the bottom row. Left of the top row, we put a box with the number we're going to divide by. And I'll explain what that means in a moment. Be extra careful if there is a missing term. You need to treat it like it's there with a 0. I don't see any questions like that on this first page here, but I do want you to be aware that that is a thing. So let's definitely watch out for that. That's the setup. Now, the actual steps. Oh, I need to move that so it's not overlapping number 2 there. Okay, so the steps are very simple. You ready? You ready? Step 1, add. Step 2, multiply. Repeat until done. And then I guess technically we need to interpret the results. So I'll show you what interpreting the results looks like when we get down to the end. So we're going to take the question that's given here, number 1, which is written in really tiny font, but it says x cubed plus 9x squared plus 23x plus 15. And we're going to divide it by x plus 15, or x plus 5. So our coefficients of the number we're dividing by go 1, 9, 23, and 15. And then we're going to make a box. I usually just do like a backwards L looking thing, but some people make an actual box. And then we need let's make a better line than that. Okay. And so this is what our setup looks like. And then we have to go, what goes in the box? Well, we're dividing by x plus 5. So the question is, what makes that equal to 0? If you wanted to make x plus 5 equal to 0, what number would you use? Well, subtract 5 from both sides, x equals -5. So this is the number we're going to put here. Or you can think of it as it's the opposite of whatever this number is here. We have a plus 5, so we're going to write a -5. All right, so step 1, add. 1 plus a blank space is 1. Step 2, multiply. 1 times the number in the box, -5, is -5. Add. 9 plus -5 is 4. 4 times the number in the box is -20. 23 plus -20 is 3. 3 times the number in the box is -15. and 15 plus negative 15 is 0. Okay, what the heck does this tell us? It tells us that, uh, hold on, let me switch fonts here. So it means x cubed plus 9x squared plus 23x plus 15, when we divide it by x plus 5, move this over here, we get 1x squared plus 4x to the first plus 3 with remainder 0. In other words, it divides in evenly. And so when we do synthetic division, we usually only care about when this number is 0. There are some exceptions, but that's usually when we are getting much more interested in functions, which is more of an algebra 2 thing, so I'm not going to address that. If it doesn't equal 0, we have divided by the wrong number, or we've made a mistake along the way somewhere. So another way of writing what we just said here is that x to the third plus 9x squared plus 23x plus 15 is equal to x plus 5 times x squared plus 4x plus 3. And that's what I really want you to think of this result as, is that we have turned our original into this slightly factored version. And so now we're going to continue to factor, and we're going to say x plus 5, and then this quadratic here we can factor further. We can say this is x plus 3 times x plus 1. So there is our fully factored version. Now, let's make sure that we answer the question that is being asked. That is always the most important thing to do with any question. And that was find all zeros and factors. Well, the factors are right here. What we have drawn right here, these guys are factors, because we've split it up into a trio of things that are being multiplied. So that is by definition what a factor is. But now let's talk about the roots, aka the zeros, aka the solutions, aka the x-intercepts. Those words all mean the same thing. So the zeros of this are going to be the things that make each of our factors equal to 0. So x plus 5 is 0 when x is negative 5. X plus 3 is equal to 0 when x is negative 3. And x plus 1 is equal to 0 when x is negative 1. So if you want to call those the zeros or the roots, they are the solutions to when the equation equals 0. And if you write that number comma 0, it is an x-intercept. All right, so that was us going through number 1. Let's go again with number 2. Number 2 says x cubed minus 7x squared plus 2x plus 40. So let's first write out our coefficients. 1x cubed minus 7x squared plus 2x plus 40. And you don't have to write the plus sign, but just to be clear. All right, I'm going to make a line, and I'm going to make my box over here, and we're dividing by x minus 5 this time. So in our box doesn't go minus 5, it goes the opposite of that. It is 5, because 5 minus 5 is 0. All right. Now we're going to go through the same steps. Step 1, add. 1 plus a blank space is 1. 1 times 5 is 5. Negative 7 plus 5 is negative 2. Negative 2 times our 5 up here is negative 10. 2 plus negative 10 is negative 8. We'll multiply that by our 5 up here, negative 40. And sure enough, we get 0, so it works. The question did provide us with one legit factor. That's kind of them. It makes this a lot easier because we don't have to guess at what our first factor should be. There are ways to do that, but we're not going to get into it. And so that means that we've got x plus 5, or x minus 5 rather, times, now this is 1x squared minus 2x minus 8 with remainder 0. Right, you're just going to say this is an x and this is an x squared, and you work backwards starting from no variable at all, or in other words, x to the 0. And now we just need to factor this completely. So x minus 5 times, all right, x squared minus 2x minus 8. So we've got x minus 4 and x plus 2 should factor that. So there are our factors. And our zeros would be 5, 4, and -2. In other words, they're the opposite of what you see in the parentheses. We've got one more on this page. 3x cubed plus 4x squared minus 35x minus 12, and it just says 3. Now, I don't know what they mean by 3, but I'm going to assume that they're telling us that 3 is a solution, and therefore we should be dividing by x minus 3. So first of all, let's set ourselves up. 3x cubed plus 4x squared minus 35x minus 12. I should be doing this in a different color because it's so close to the other one. All right, let's pick a different color. How about this lovely shade of green? 3, 4, -35, -12. Okay. And we're going to be dividing this by x minus 3, or in other words, we're just going to stick a 3 here in the box. Again, I want to emphasize that this is dividing by x minus 3. Okay, so first we're going to drop down our 3, and then we're going to multiply by the number in the box, 9. We'll add 13. 13 times 3 is 39. -35 plus 39 is 4. 4 times 3 is 12. -12 and 12 is 0. So there we go. We've got a fully factored, well, partially factored form of x minus 3 times 3x squared plus 13x plus 4. Ew, that is gross to factor because we've got a lead coefficient. It can be done. You can factor that, or you can go through the quadratic equation if you prefer, and the numbers you get will be x minus the first thing, x minus the second thing. But I feel comfortable enough factoring this because I'm going to say we need an x and an x. One of those has to be a 3. And then we need either 1 and 4 or 2 and 2 in back. And to get a 13, I'm going to need plus 4 here to make 12, and plus 1 here to make 1, and 12 and 1 is 13. And if that didn't make sense, pause, slow down, and think about it, or factor it yourself through your favorite method. But it should work out to this. So there are our factors. And the zeros then are going to be from the first term, x equals 3. From the last term, x equals -4. But what about that middle one? 3x plus 1 equals 0. All right, so if 3x plus 1 equals 0, that means 3x equals -1. And if we divide that by 3, we're going to get -1/3. That is the number that will make that term equal to 0. Whether you write x equals or not is up to you. It really is kind of up to the taste of your teacher here, but that will solve these 3 questions, these synthetic division questions. So hopefully that addresses that. Now I'm going to scroll down here and look at a couple additional questions. So I'm going to, I guess I better clear the screen here. I kind of wanted to leave the steps up, but I'm just going to hit clear. Okay. So we're going to then do the exact same thing with these questions. And so, you know what, before we go any farther, I'm going to zoom in just a little bit to make sure that it is visible what we are doing, because I feel like this is tiny text and I want you to be able to see better. Okay, so now, hopefully you can read that a little better. It says 5x cubed plus 9x squared minus 26x minus 24. So let's go through our process again. The steps, as I recall, are going to be exactly the same. Yeah, given one factor, find all zeros and factors. So it's the same instructions. They're asking for the same thing, so we're going to do the same thing. We're going to set up our synthetic division. We've got a 5 and a 9 and a -26 and a -24, and we are dividing by x plus 3, which means the number in our box is going to be a -3. All right, and now we're going to do our add multiply game. Like so. Again, we're multiplying by -3 when we come up this way each time. And the downward stroke, we're just adding what's in the column. All right, so what do we got here? Well, we divided by x plus 3, and our result was 5x squared minus 6x minus 8. Ooh, okay, that's going to be harder to factor. So rather than factoring it, I'm going to go ahead and I'm going to do this with the quadratic formula because this seems nasty. So how are we going to do that? Well, all right, so we've got oh, I don't like that color. Uh, A equals 5, B equals -6, and C equals -8. Give myself a little more room here. Let me drag it, please. Thank you. Okay. So uh, when we solve that quadratic, we have -6 plus or minus -6 squared minus 4 times 5, -20, times -8 is plus 160. Okay, we're going to get some big numbers here. Over 2 times 5 is 10. If you have forgotten your quadratic formula and you're not sure how I got there, I strongly suggest that you look it up and then write it down. Keep writing it down until you're familiar with it, because you do unfortunately need to have that down pat. You will need it for later math, maybe not in geometry class, but you will certainly need it elsewhere. So 6 plus or minus, all right, 36 and 160 is 196, and the square root of 196 is 14 over 10. So we either have 6 plus 14 over 10, which is 20 over 10, or 2, or we have 6 minus 14 over 10, -8 over 10, which reduces to -4/5. So these are our two other zeros. But then how do we write this? Well, at first glance, it would be x plus 3, the one we had before, times x minus 2 times x plus 4/5. That's what it would appear to be. However, you're going to notice that there was no way to get a 5x squared if we factored it into this and this. And the reason for that is because we don't have fractions here. And so what we actually do is we clear the fraction here. There was a 5 that we had actually pulled out. It's like 5 times all this stuff. The real way we're going to write this, just trust me on this, the real way we're going to write this is we're going to say x plus 3 times x minus 2. And now instead of x plus 4/5, we're going to write this as a plus 4. And this is not x, but rather it is 5x. So that would be the properly factored version. Or you can pull the 5 out front if you really want to, but there has to be this 5 here somewhere. So that 5 has to exist. So our zeros are 2, -4/5, oh, and -3, by the way. And our factored form is right here in the brown. Finally, we're going to do one more. I think we'll settle for one more here because I think we're getting the idea. So one last question. We're going to look at number 2 here. 5x cubed plus 4x squared minus 20x minus 16. And we're going to use a 0 of, or an x-intercept, a solution of x equals 2. So one last time with the synthetic division. We got more space here, so I'm going to write nice and big. 5, 4, -20, -16. We're dividing into that with x minus 2. 5 plus blank is 5. 5 times 2 is 10. 4 plus 10 is 14. 14 times 2 is 28. -20 plus 28 is 8. 8 times 2 is 16. -16 plus 16 is 0. So we've got x minus 2 times 5x squared plus 14x plus 8. And once again, that is going to be pretty awful to factor, I imagine. Can I figure that one out in my head? 5, oh, it's 10 and 4. Okay. Yeah, actually, I can do that. X minus 2. We have 5x and x. And we're going to multiply the 5 by a 2. And we're going to multiply the x by a 4. And now if we were to FOIL that, we would have 10x plus 4x is 14x, and then 4 times 2 is 8. So that does work. If you're not comfortable with that, do it with the quadratic formula. Just be aware that when you do the quadratic formula, the answer you're going to get is not going to be 5x plus 4. You're going to get something that seems to suggest x plus 4/5, and then you have to clear the fraction. The reason we clear the fraction is because there were no fractions in the original question. So there's probably not going to be fractions in the result. There might be fractions in our zeros because we solve this for 0 and we end up with -4/5, but the actual factored version should not have fractions in it. So that is a rundown of all this garbage that we have done today with quadratic formula and quadratic equations and synthetic division. I hope this was helpful, and I'll see you next time.